I'm really excited to be here. As mentioned, this talk is called Squish Meets Structure, Designing with Shoggoth. So first, just to give you a little bit of context of who I am and why I'm talking. My name is Maggie, as mentioned. This is what I look like on the internet. I'm currently a product designer at an AI research lab called AURT. I'm also a mediocre developer, and I was a cultural anthropologist originally by training, which really ties into a lot of my design work. And then I do a lot of writing and research publicly on the web about kind of tools for thought and end user programming, if anyone's familiar with those worlds. And those have ended up tying into a lot of this kind of new world of language models that I've started working in since about a year ago. So I want to give you a little bit of context about AURT, which is the lab I work for. So we are a research lab, but we're also a product lab. So we build products, and we're really focused on AI alignment and safety, as well as kind of building useful things for people. So as mentioned, I've been there a year, but the rest of the team has been thinking about language models just like way before this whole hype cycle began. So they've been trying to build products around language models since about 2018. And they've developed a really opinionated approach to how we should build with these models. And I felt incredibly lucky to get to kind of work with these people and learn from them, because they've just been kind of understanding these systems from a much more fundamental level than I think most people do at the moment. And I'm really excited to kind of share some of those insights with you. So both their thoughts and ones I've developed by building with these for a year now. So the main thing we're building is this tool called Elicit. And Elicit is a professional research tool that's powered by language models. It's been running for about 2 years, got about 100,000 users. And it's primarily for really serious full-time researchers. So these are people who are like full-time academics, people who work for large NGOs, people who work for governments. And the thing we're primarily doing is we're helping them do what's called literature review, which is when kind of researchers have to read hundreds or possibly thousands of papers when they're trying to understand the current state of a field or topic. They like need to know what the most recent and up-to-date science is and the history of that. So I want to show you a little bit about how Elicit works here. So this is our main interface. And you can kind of come in here and you can ask a research question, or you can just type in a topic you want to learn about. So I'm going to try to learn about, let's say, human versus computer tutors, right? This is like a very popular topic at the moment. We think we might all kind of be being taught by AI tutors in a minute. So what I can do here is I can brainstorm research questions, first of all, to be like, well, kind of like, what question should I be asking about this? So it gives me a bunch of ideas. And this first one seems pretty straightforward, right? Like, how effective are computer tutors compared to human tutors? We're going to do a little search and some things are going to load in here. We're going to give it a second. So what it's returned here is a big list of papers that it thinks is most likely to answer this question I've asked. And we're using language models in the background to kind of rank the relevance of these papers. And then we're doing a couple other things with language models in here. So one thing you'll see here is we're summarizing the abstract of each paper in a single sentence. So the abstract is usually kind of a single paragraph that summarizes like the main findings of a paper and the methodology and just kind of the conclusions they got to. And we're just like cutting that down to a single sentence, so it's very easy to scan. And we're also generating a long paragraph right here on the side that directly answers the question they've asked and kind of shows inline citations to papers with supporting evidence. So these papers suggest that computer tutors actually are as effective as human tutors, right? We can kind of see some effect sizes going on in here. And we can click on one of these papers and then investigate these answers that we've gotten, right? So here we can click on this abstract summary, and it's going to highlight the bit of the text where it found that answer in. And we kind of go down. It didn't actually find some of these other details like participant count. Let's find one of the papers that did know that. So let's try this one over here. See, this one says 20 subjects. This is usually quite important for researchers. It's like, well, how many people did they study? You know, is this 5 people, or is this 2,000? If I click on this, it'll scroll me right to the section of the paper that shows how many people there were in this study. So essentially what we're just doing here is we're trying to make it much faster for researchers to be able to extract this like really key information from papers, which usually they have to read the whole paper and like find all the information. It's this very time-intensive, laborious process. So this is just one way of using language models, but I wanted to show this just to give you some context about the kind of systems I've been working on and the kind of ways that AURT and Elicit are approaching language models. So let's pop back to our slides over here. Right, so I just wanted to give some context, but this talk isn't going to be about AURT and Elicit. It is primarily going to be about why language models are such a mysterious, finicky pain in the butt to design with. It's going to be about some other things too. It's going to be about some useful ways to think about language models, kind of what mental models we should be using to kind of reason about them. It's going to be about the tension that we're currently feeling between traditional programming and language models. And it's also going to be about how you can design models to kind of be tiny, specialized reasoning engines, which is just the opinionated approach that Ort's taking that I strongly believe in too. So back to this for a moment though, right? Like, why are language models such a pain in the butt? I'm sure we've all at this point heard something along the lines of like, well, you know, ChatGPT lies, right? ChatGPT has become this huge phenomenon in our culture, and it's become this like Twitter meme or this like, you know, news media kind of hype headline to kind of be like, oh, well, ChatGPT is just lying all the time. It says things that aren't true. I think this is a very oversimplified way of talking about the limitations of language models. And it kind of fundamentally misrepresents how they work, because a language model can't lie, right? Because a lie is something that a human does to intentionally misrepresent the truth for some motivated reason. And language models have no notion of truth. And they also don't have any motivated reasoning, because they're not trying to do anything other than predict the next word in a sequence, right? They kind of aren't trying to like manipulate us, not yet at least. So I don't know that this is the right way to talk about it. But I do think that we should have a very robust understanding of language model limitations and why they happen. And I think this is incredibly important for people who are going to be designing products and building products using language models. So I'm sure you've already heard some of these, right? Language models are really quite unreliable and unpredictable in the kind of outputs they give back to us. Every time we prompt them, we almost really don't know what's going to come back to us. We have to do a lot of work to make that response quite predictable. They hallucinate. This is, of course, the thing that you hear when we say they're lying. They say things that do not accurately reflect reality, right? They are not grounded in the truth. They have very opaque reasoning, right? Like, we don't actually understand how language models are doing their internal reasoning. We maybe know a little bit about the architecture, but we don't actually know how they make decisions, which I'll talk about more later on. They can't explain themselves. Like, if it gives you an answer and you ask something like ChatGPT to explain why it gave you that answer, it can generate a bunch of text that seems like a plausible explanation, but it's not actually explaining itself. It's just generating more text. And finally, I think the one that is the most difficult to grapple with is that they are simultaneously very capable, right? But also frustratingly dumb. And this like contrast is probably the most confusing thing for us. So I'm sure you've all seen examples like this. This is Google's Bard chatbot. And here we've asked it, where are the N's in mayonnaise? And Bard has said there is no N in mayonnaise. And then it kind of goes on about like the origin of the word mayonnaise being derived from French, but continues to insist there is no letter N in it. And then goes into the history, which is like irrelevant. And this feels very strange to us, right? Because language models are supposed to have like this very sophisticated understanding of human language, right? They have learned how to put together real kind of strings of words that feel very sophisticated to us. And yet they kind of fail to understand this basic thing of like where the position of a letter is in a word that they just typed. And so kind of look at this and you try to figure out like, well, how is this possible? And actually there are tons and tons of these limitations and failure modes of language models. And there's so many, I kind of can't like run through them, but I wanted to show this repository called ChatGPT Failures. This is a GitHub repository that collects all the possible failure modes of language models. I think this is really useful to go look at. They have all these kind of screenshots like showing you exactly all the ways that they fail, right? They fail to do arithmetic. They have biases. They kind of fail on common sense. They fail at games. They fail at all kinds of things. This is a really interesting repo to look through. So I'd highly recommend looking through that. But otherwise, we just don't have time to kind of do the laundry list of all the ways that they like are bad at some things. And the problem is we have to then reconcile all those limitations and failures with something like this. So what we're looking at here is a graph that was part of the paper that OpenAI released when they released the GPT-4 model. So for people who don't know, GPT-4 is what most of us would consider one of the most capable models on the market right now. It was only released a few months ago, and they kind of put out these results with it that showed how it performed on a bunch of really difficult human exams, right? So kind of like the hardest exams we have that we give to humans, right? The bar, the SAT, the LSAT, the GRE. And GPT-4 consistently performed in like over the 90th percentile in almost all of these exams. And even though they're like, kind of standardized exams, right? And we might think of them as maybe being a lot of rote memorization. Some of them really do require some advanced reasoning. And it's really hard for a human to get over the 90th percentile in them. So it's like we're trying to figure out in our heads, like, well, okay, they like can't tell me where the letter N is in mayonnaise, and yet they're able to score like in the 99th percentile on the GRE. And so it's so hard for us to reason about how these two things could both be true. So I call this capabilities gaslighting. For people who don't know, gaslighting is when someone in your life purposefully tries to make you think you're going crazy, kind of by denying your reality and manipulating you and lying to you. So they might do something like go on a trip with you and then later deny that they were ever on that trip. And you kind of start going, well, am I crazy or are they lying? And like kind of lose touch with reality. Or imagine if you had like a really crazy roommate who like hid all the forks in the house and then like lied about it and acted bewildered about where they had gone. And so you would like buy more forks and they like hide those too and then continue to lie about it. And then you think you've developed like fork blindness disease. So it just makes you like question whether you're the sane one or whether everything around you's kind of gone wrong. And that's exactly what it feels like these models are doing to us. Like it feels like they're either geniuses playing dumb or incredibly dumb machines playing geniuses, but like we don't know which. So I think we do need to understand why they're like this. And to do that, we have to understand a little bit about how language models work. And so I find it helpful to think about language models as being squishy. And by squishy, I mean that language models feel like something that is a little bit kind of organic and biological, rather than something mechanical that we've made. Like it feels like we grew them rather than that we built them, right? We don't fully understand how they work, which is very unusual for a creation. Like it would be strange if we had made a car and then we didn't exactly understand how the wheels turned. But that's the situation we're in. They're also a little bit evolutionary. They don't totally mimic the process of evolution, but they learn to perform well in these tasks we give them through trial and error and feedback. So it is a little bit like evolution, right? They're adapting their techniques to be successful in a certain environment. We also made them through a process called deep learning that mimics how neurons in the brain work. So they kind of do have a biological basis to their architecture. And they also have this really emergent surprising behavior that we kind of need to study in order to find out, which is a little bit like natural phenomena, right? Like the biological world, we kind of have to run experiments against it, and then we figure out exactly how it works, but we can't do it by sort of breaking apart the pieces and looking at them individually. So a lot of AI researchers and machine learning scientists often talk about language models in similar terms. They kind of call them like alien minds we've stumbled upon. So this is Andrej Karpathy, who is incredibly famous in the AI world. He was head of AI at Tesla, and he makes a lot of educational content around AI and ML. And he went on this podcast with Lex Friedman, and he said, I think of neural networks as a very complicated alien artifact. And this feels to me like the general consensus of what I hear when I talk to other ML researchers, is that they all have this concept that like we don't fully understand what we've created. And the reason for that is that language models are a mystery because they kind of have this set of hidden layers in their architecture. So what we're looking at here is the structure of a neural network. And we have our input layer, which is the kind of like data and the goal that we feed into a language model. And the language model creates these hidden layers that we can't quite look at or inspect in the middle, where it does its reasoning to figure out how to get the kind of output that it knows that we want. So to talk about this a bit more in detail, when we train a language model, we give it a goal and we say, okay, given this sequence of words, I want you to predict the next word, right? So the quick brown fox, fill in the blank. And then we also give it a huge amount of training data, right? We just give it this huge scrape of like all these human words that have ever been written to the internet. And we take these and we feed it into a neural network. And then that neural network develops these hidden middle layers that kind of pays attention to different patterns and sequences in the data and figures out what kind of words come after other words. And then it's able to give us a result that in this case, the right answer would be jumped is the most likely word that's going to come after the quick brown fox. And then what we do is we give the model feedback, right? So if it does well and it guesses something that is predictably the next word, we give it a reward. And if it gives an incorrect word, we give it a punishment. And so it kind of learns through this looping process how to set up those middle layers in a way that will always give us the output we want. But we still can't look at those middle layers and like figure out exactly what kind of decisions it's making. So this is what makes it a little bit of a black box. So it's a little bit like speed running evolution, right? It's like, okay, I need you to find an effective way of achieving this goal based on trial and error and feedback loops. I need to be careful about this because there are also algorithms that are a lot more evolutionary kind of based that we use to train language models. So this one's a bit like proto-evolutionary, but it still makes it feel like a biological system. So this like squishy biological nature that's kind of in the ether of the AI world has made the community develop a kind of mascot called a Shoggoth, which is what you're looking at. And there's been a lot of kind of memes and jokes around this Shoggoth creature. So Shoggoth is actually a character from H.P. Lovecraft's poems, who's a 20th century writer. And he described them as a massive amoeba-like creature made out of iridescent black slime with multiple eyes floating on the surface. Right? Doesn't sound very nice. So we've kind of all taken this in like AI Twitter and run with it. So there's lots of memes on memes on memes. This one here is kind of showing the nature of something called RLHF. RLHF is reinforcement learning with human feedback. And all that means, it's a fancy word, that it simply means that we ask the model a bunch of stuff and then we get humans to rate the output. And they kind of say, I like this output, I don't like that output. And the model learns to only show us answers that it thinks will score well on what these humans are rating. But there's still this like big kind of crazy squishy monster behind this like happy little mask we've stuck onto the front, which is the RLHF. This is a much more visceral version of that same meme. Someone with a little more illustration ability kind of joined in here. And again, what they're getting at here is that this unsupervised learning piece, this like huge gross monster, is pointing at all the training data that we use to train these models. It's this like massive data dump of essentially all the text we could get our hands on. So this is like everything on the internet, everything on Reddit, all the books, all the Wikipedia. And it's called unsupervised learning because this is so much text that you could never scan it all. You can't check it. You can't like make sure that it's not like racist or inappropriate. We just don't have the time to read it all. So it's kind of this big, gross, massive text. And then what we see when we use something like ChatGPT is only the kind of outputs that have been trained on supervised fine tuning. So that's when we actually go look through certain data and we point the model at like, this is a good answer, this is a bad answer. And then we do the RLHF, the human reinforcement, human feedback on top. And that really is like, we're rating answers we think it should pay attention to. But we still have this kind of big gross monster underneath, which is the tricky thing to deal with. So given that these models are these like untamed, squishy biological things, we kind of have a core tension that we need to navigate when we're designing and building with them. And that is squish versus structure. So we are trying to make an unpredictable, opaque system adhere to our rigid expectations of how computers should behave, right? We currently have a mismatch between our old mental model of how computers work and this new mental model that we're trying to very quickly develop. Because the selling point of computers up until this point is that they are incredibly predictable and structured and reliable, right? They do what we tell them to do and they do it repeatedly and they do it without getting tired, which is way more reliable than a human. And it's why we put them in charge of things like making sure we all get our salaries paid on time and tracking a patient's vital signs during surgery and controlling traffic. And like, we do not want humans doing these things. Like, we are very bad at them. Like, we're not good traffic controllers for, you know, a 24-hour period. And we can often complain about the way that like computers will fail and that they kind of fall short on some of these things when we really expect them to be kind of on it and predictable. But that only emphasizes how much we take that quality for granted, that they're going to do the same thing we want over and over and over, millions of times over. And this is how we're used to them working, right? You kind of like have a device and it has a very familiar interface that maybe has a button on it. And you press the button and like a very predictable series of logical functions execute, right? And we can see exactly which functions are running. And if there's a bug in that code, we can go track it down. And this whole system is very observable and it's transparent, it's predictable. It's sometimes rigid to a fault. Like, we're sometimes like, oh, why do you always follow the rules? That's so frustrating. But it makes it that this is like how we expect them to work. And what we're currently doing with language model interfaces is we're presenting users with the exact same kind of device and the exact same interface. And instead we're like feeding it to this squishy Shoggoth monster, which then sends back something totally unexpected that like just does not work the same as traditional programming logic. And this mismatch, I think, is kind of what's causing these like wild reactions to something like this. So this is Microsoft's Bing chatbot, which obviously made a lot of headlines. Bing was kind of infamous for the person would be talking about something totally unrelated, And Bing would start declaring its love for the person it was talking to and kind of being like, I love you, like, you're the reason I wake up every morning, like, I want to kiss you. There were some other screenshots that I didn't feel comfortable putting on these slides because they were frankly too explicit, but you can look them up in the repo of failure modes. But this is just very novel and unexpected behavior for like what we thought of as an automated chatbot. And like normal everyday users are not prepared to receive this from a chatbot interface. So I feel like we really have a lot of work to do around like making it so that people aren't kind of frightened or taken aback when they start interacting with these language models. And because the problem is, like, we're using the same interface primitives that we always have, but then letting users interact with a very fundamentally different type of technology. And the expectations here are just completely mismatched. Right? And like predictability is supposed to be the hallmark of good UX, right? We all know that like the user should know what to expect, and they should never be faced with kind of results or feedback that seem out of the blue or surprising to them. And I still think this is probably true, but we might have to start rethinking this as we use more generative and emergent systems in our design work. We might have to kind of consider predictability something you sometimes want, but not all the time. We might become more flexible, but for the moment, like, I feel like this still stands. And so what we need to do at the moment is we need to learn how to put Shoggoth in a box, right? We need to learn to put some predictability and control onto this crazy monster, because we can't just expose normal people to this, like at least not in its current state. And most of the work that the community is doing around language models is trying to constrain their behavior with various techniques. So just to run through a few of these, you kind of have some of the vocabulary and language to talk about this stuff. One of the first ones is called fine-tuning with gold standards. So what this means is you kind of make a bunch of examples of what the idealized output would be of what you want, and then you tell the model to pay more attention to that. So you kind of fine-tune it on this smaller data set. Another one I mentioned a few times before is this is the reinforcement learning with human feedback. This is when you get humans to score the output of the model, and then you feed that back in so it learns what you like and don't like. Another one is called prompt chaining. I'll talk more about this in a minute. This is when you chain many prompts together and you have observable inputs and outputs. So you can kind of do more complex, sophisticated things. And then lastly are chain of thought and what's called react prompting. And this is essentially when you try to make the model reflect on its answer to improve its accuracy. So you kind of say, okay, you've given me an answer. Do you really think that answer is correct? And sometimes the model's like, oh, well, actually, no, that answer is not correct. Let me try again. And these techniques help us try to get the best of both worlds, right? Like the Shoggoth creature is really interesting, and it has a lot of potential for kind of creative, open-ended exploration, but we have to figure out how to guide it and direct it at very sincerely useful tasks. So most people do this through something that's called prompt engineering. And prompt engineering is a technique for kind of exploring what's called the latent space, or the possible space of answers, by writing like really long, specific, sometimes quite strange prompts to kind of constrain this space. So here's an example of a very simple prompt. Prompts are usually something like this. You kind of have this like open text input on something like ChatGPT, and we request something from the model. So here I'm thinking, okay, I want some text that sounds like Malcolm Gladwell wrote it, but Malcolm Gladwell with a lisp. And I want a paragraph that's going to be about like modern forms of alternate education. Like, let's see if the model can handle a request like this. So this is what we get back, which is actually quite good. It like mimics the way Malcolm Gladwell tends to write, but it's understood this concept of having a lisp, right? It's like put in THs everywhere there would be S's, which seems honestly quite sophisticated for it to have understood that. And then the topic is correct. It's about alternative education. Maybe at this point we're kind of jaded that it can do this, but I'm still blown away by outputs like this. Like it seems very sophisticated, despite all those other limitations. So we kind of have to think about this concept of like querying latent space. So I want to do a little visual to kind of explain how an output like that comes to our screens. So latent space is this idea that you have to think of as kind of this enormous multi-dimensional space of all the possible strings of words that we can make in the world, right? Just like an immense multi-dimensional graph of like all possible things you could say. It's like somewhere in latent space, there's like the sentence from Dickens's classic novel, "It was the best of times, it was the worst of times." And like somewhere else, there's the sentence like, "Where is the vacuum cleaner?" Right? Like every possible string. And we're trying to query this space to get the exact string of words that we think will be most helpful to us to like learn something new or accomplish a specific task, right? We do kind of know the area of what we want to receive back, but it's hard for us to know exactly what that string of words is. So when we query for something like, give me Malcolm Gladwell with a list talking about alternative education, we're kind of querying these fuzzy areas of the latent space. And then we're doing a mathematical probability calculation that says, okay, like find me the intersection of these things. And it's incredibly hard for us to predict exactly what prompt will lead to the string of words we want that will best solve our problem. But you kind of learn by prompting many times and beginning to do kind of longer, stranger prompts of how to kind of narrow this latent space down to exactly the one that the part that you want. You could often have to do strange things like compliment the model. It often helps to just do things like tell it that it's super smart, that it's really knowledgeable, that it's like a really good critical thinker, and then it's going to return higher quality responses. And this kind of makes sense, right? Because you're sort of narrowing down into the area of latent space that's like, this is written by smart people, this is written by knowledgeable people, kind of narrowing it into a space of kind of higher quality answers. So it helps to think of latent space as this like edging out fuzzy areas. So I think our like biggest design challenge for designing language models is this finding this ideal balance between Squish and structure. So we kind of have this tension, and we're trying to figure out exactly what kind of middle ground we need to be in to get the right amount of predictability and flexibility. Because this feels to me like a spectrum, right? We kind of have on one end like wildly open-ended, like Shoggoth Squish, and on the other one, like perfectly structured, predictable, like traditional computer programming. So there's a couple of ways that we can like play with these two. The first is temperature, and temperature in language model world is setting exactly how much randomness is in our language model's response. So having a temperature of 0 means that the language model is going to return the most predictable words it can. Right? This is just like what is most likely to be the next word in the sequence. And having a temperature of somewhere over 0.7 is where things get a lot more creative and kind of weird. We can also play with things like RLHF, so like how much RLHF has been done on a model. Models that have not been RLHF are sometimes called the base model. These are usually actually not open to the public. Like you can't access the base model of like OpenAI or Anthropic. The base model usually probably isn't very good. It's like a purely unfiltered version. It's usually like kind of quite explicit and probably pretty racist and unsavory because it's just like a chaotic string of everything that's being written on the internet. So you can imagine how bad that is. Another way we can play with these is how much prompt engineering we do. So if we do almost little or almost no prompt engineering, you're going to get much weirder, more creative stuff out of models. And if you do these kind of like highly constrained optimized prompts, right, where you're testing many prompts and you're really finding like the most efficient prompt to achieve a certain task, you're going to get much more structure and predictability out of it. So obviously on the left, we kind of have opportunity to find much more surprise and much more creativity. And on the right, we have kind of much more predictable formatting and outputs. And it's not that either of these is like the right or wrong end to be on. It very much depends on your use case. So like if you're designing a product that is trying to like help people write really weird poetry, you probably want to be closer to like the Squish side. And if you're doing the kind of work that we're doing at Aut on Elicit, it's like extracting information from scientific papers. You really want to be on the structure side. You're kind of just constraining the model to only do a few small things. So what we want is like probably somewhere here in the middle, right? This is like the Goldilocks zone of Squish and structure. Like too far to the right, and like honestly, you might as well not be using language models for this kind of task. This is something like if you're trying to do keyword search, like using a language model is a super ineffective use of resources for keyword search. And then like if you go way too far to this side, I don't think this could actually be useful for anyone. This is where it just gets into like strange territory. To show you an example of this, like so this is OpenAI's playground. Some people might have used this. And what I'm going to do here is turn up the temperature on this model up to 2, which is super high. Like it's going to get really weird here in a minute. And I'm going to ask it like a fairly boring question. I'm going to be like, okay, what should I read to learn more about architectural history? I'm going to see what this like very high temperature model says. So it starts off with like what could be a reasonable answer. It's talking about like libraries in Portuguese grounds, which is very strange, but it's saying English words like in a sentence. I don't know that they actually make sense. It gives me something that looks like a citation to something. And then after this point, it just completely falls apart, right? Like it now goes into what could be Latin, like there's some strange punctuation in here. This is a very strange, like citation looking thing. And then we just go into like gobbledygook nonsense. These are not words, I don't think, in any language. But then it like throws in random like sensible words here and there. So you can see how fast it falls apart if you turn the temperature up really highly. I don't think this is what we would call good creativity. unless you're trying to invent like brand new words for your like, I don't know, experimental fantasy novel, there's not much practicality to this. But it's interesting to see what happens when you kind of like take the guardrails off. So yeah, I think it's like we need to figure out a few ways of solving the Squish problem. As I mentioned, RLHF, like better quality training data, you know, fine tuning, these are all ways to do it. But the main way that we are solving it at ORT is we're making language models compositional, and we're also treating them as tiny reasoning engines. So compositionality is quite a simple idea. It's saying like, what if we take these like really large, complex cognitive reasoning tasks that we want language models to do, and we break them down into smaller, much more manageable subtasks, right? Like we can't trust the crazy Shoggoth to like do big complex things, but we can constrain its outputs on kind of very small specific things and use those to build up into a bigger thing. So for example, let's say I'm trying to answer what seems like a simple question, but actually it's quite complex, right? If I say, okay, is taking calcium supplements a good idea? And if I were to use traditional ChatGPT, it would be one input, one output, right? I would just like ask the question and I would get an answer like this, where like ChatGPT is like, right, I'm not a doctor, but like, here's what calcium does, and like, maybe you should consider it. It's very hard for me to see the model's reasoning in this answer, like how did it get to this answer? And it's very hard for me to validate it. Like I have no sources here. I don't know whether to believe this. I can like Google it and double check it, but like this is not a transparent answer to me. What we would do with composition is we would take that question and we would break it down into lots of sub-questions and subtasks. So this first question is actually quite complex when you think about it. What we're asking here is a whole bunch of stuff. We're asking like, well, what are the benefits of calcium supplements? What are the risks? Like who shouldn't take them? You know, what are they commonly prescribed for? You know, what are the most cited and well-respected scientific studies on it? And what we can then do is kind of go through and answer each of these sub-questions one by one, and then use those to compose a much more comprehensive answer to the first question. And importantly, we're then going to be able to see the inputs and outputs of each step, so we can like double check each part of this. And we could break each of these questions down more and more and more, and we could bring in other systems like checking against scientific papers to actually make the answers to these questions more legitimate. But that's all compositionality is we're just saying we're going to take the big complex thing and break it down into small things. And we can then take this a step further. There's something that's become quite popular called prompt chaining that was popularized by a library called LangChain that some people might have heard of. But we've also been doing this at ORT for a while. And what we do here is we can not only break language model calls down into smaller pieces, but then we can kind of compose these chains where we feed the inputs and outputs into each other, but we also give it access to external tools like web search, right? And code repls and calculators and databases to store long-term memory. And then we can also bring in external data sources like scientific papers and again, web searches. And this helps kind of cut down on hallucination. And by using these chaining techniques, you're able to build up much more complex, much more sophisticated and reliable and often truthful answers to questions that aren't just like input, you know, crazy black box output, but input output into many small pieces while bringing in lots of external outside data. So here's a very real example of a compositional call that we use in Elicit. So one thing we often have to do is answer a very specific scientific question, like, did this study use a placebo? And if so, what was it? Right? So often in scientific studies, if they're saying, okay, we have this drug and we want to see if it's effective, then we also need to test a section of the population with a placebo, right? Like a fake drug, just so that we're checking that like the variables aren't out of whack. So what we're going to do here is we're going to feed a PDF paper in, and we're going to ask this question, but we don't just ask the question to get the answer, right? We break this down into many pieces. First, we're going to get what we call the trial arms. These are like the two sections of the study and seeing what they tested. I'm going to do that by first getting the names of the trial arms and then getting the descriptions. And in order to get the names, you first have to break the paper down, paragraph by paragraph. And then for each paragraph, ask that paragraph, you know, given these two paragraphs, compare them, which one better answers the question, what were the trial arms of this experiment? And so you rank the paragraphs for relevance. Once you have that, you take the top 3 paragraphs and then you ask them that direct question, what were the trial arms of this experiment? And then you're much more likely to get the correct answer. And then again, the important bit here is that we can see the inputs and outputs of every single step of this process, so that we're not like in the dark about how it got this answer. We know we can point to, okay, it said that the answers in these few paragraphs, we can read those paragraphs, we can double check that answer, we can build this answer back up into a comprehensive thing. And this is really important specifically for our work, working with researchers who like really need accuracy and really need to know the answers we're giving them are true, this approach works really well. So we design each of these compositional systems to be a little bit of like a tiny reasoning engine, right? Like that placebo example, that composition only answers that question, like, does the study use a placebo? But then we make lots and lots of these, right? We kind of optimize for things like have a language model summarize this text, or have it extract certain data, have it compare and contrast two different arguments, have it group arguments by certain characteristics. And then what we're able to do when we have these kind of tiny reasoning engines is we can bring in any data. We can bring in, you know, a whole bunch of scientific papers. You could bring in your own personal notes database. You could bring in a public database like Wikipedia, and you could feed that into these little tiny reasoning engines. Again, have all these small observable inputs and outputs. You're always checking those answers. And then you're going to be able to get answers that have much less hallucination in them and are just easy to kind of be transparent with and double check. Right, and the big large point here is like we shouldn't be outsourcing large chunks of complex reasoning to these opaque models. If you can't see how the model reasons, you really can't trust its reasoning. It's actually quite irresponsible for us to be using these models for very large complex tasks without being able to see how they work. So I've been talking a lot about like the technical implementation side of language models, like how you should kind of compose language model calls. But I think these principles definitely apply to design to like front-end design. Right, like at the moment, there are a lot of interfaces that I feel are trying to outsource way too much cognition to language models. Like I see a lot of interfaces that essentially look like this, right? They're like, here's the AI magic tool, like, and they just ask the user, like, what do you want to do? You can do anything at all. Like, ask the magical AI box to do something. I just don't think this is the ideal interface, because the thing is, the user's like, okay, well, like, what can I do here? Like, what should I do? Like, what is this tool for? Like, what are you asking me to do here? The thing has no affordances, right? Like there are no knobs or door handles or like things to grab onto here. And it's just offloading all the cognitive labor to the user. And then they have to figure out what it's capable of doing. And it can't actually do everything, right? Like if they ask this, you know, what's like a mathematical calculation, it wouldn't give them the right answer. And also if they asked it to like deliver them a large cappuccino in 30 minutes, like it wouldn't work. So I think this thing just like is not an accurate representation of the way we should be presenting these models as like these universal interfaces. And this is a fake example, but like if we look at Notion's current implementation of language models, like it's not different to the previous screen. Notion do have other pre-baked commands you can run, like you can like summarize things or generate text, but like a lot of their stuff is just kind of defaulting people to being like, well, just ask the magical AI anything you want. Which is not directing people to like solve a very specific problem for themselves. You also just like can't call everything AI in design copywriting. Like I'm also super against this. Like I think you have to say what the thing you've designed actually does, and it can't like do AI. Like AI is not. I mean, AI is a problematic term anyway. Like goodness knows what this actually means. I just think it's such a cop out to just be like ask AI to X in any interface. So like I would like to strongly veto this. I think instead, what we should be doing is trying to make very like tiny, sharp, specific tools, right? We should be designing language model products to do like one thing really well, or one feature that does one thing really well. So to contrast the previous example, like imagine an interface where you are like writing, maybe you're doing some research writing, and it gives you a set of very specific commands to run. And right, we can imagine that each of these commands is linked up to a compositional model on the back end that's like optimized, do each of these really well, right? You could highlight text and say, okay, critique this, rephrase this, like identify assumptions in this, find evidence for this. I feel like language model products should be like spell check size, like just one thing, super well. Okay, so I want to start wrapping this up. So to summarize everything I've said, we should first think of language models as kind of like squishy biological creations that we have to investigate to understand. We should be trying to find the Goldilocks zone between like squish and structure for our particular use case. And we should be treating language models as tiny specialized reasoning engines, not like a universal text box to answer all questions and do everything for us, because it will do neither of those things. So I want to thank you very much for listening. I have some writing up on MAGGIE.com, some stuff on language models, but a lot more on like tools for thought stuff. I'm on Twitter at APPLETON, and if you are interested in the research products or Ort's research, there are links to Elicit and Ort there. But yeah, thank you very much for listening. I'll see if I'm still on screen. Oh, I can't hear you, Tejas.
It's Tejas. Sorry, I was muted.
You just, sorry.
That's all right. Thanks for that presentation. It was so insightful and useful. The data was really comprehensive, and I learned a ton. I would invite the audience to leave some questions if you want to. The link is smashed.by slash. Let me see if I can get this right. Smash.by slash. Gosh, where is it? Can someone slash meets dash AI? There you go. Thank you for that slide. Yeah, in the meantime, there are a couple of questions here, Maggie, that if you'd be willing to answer, I'd really appreciate it. These are questions
Sure.
from me. I
Okay.
thought your talk was so interesting that I added these here.
Cool.
First question, you talked about the kind of Goldilocks zone between squishy and structured. And you mentioned if you're doing a keyword search, then you don't really need a large language model. So I was curious, based on when you said that, what would be a good case for when you do need a language model versus when you need something more structured?
Yeah. I think anything where we like just don't have good systems to or current like programs, like something like summarize. Like it's really hard to get a current programming system to like summarize something well. Whereas like that is what our language model does amazingly well. Or like rephrase in a certain tone of voice. Like I really love like things like generating critiques of arguments, generating further research questions. Like it has tons of strengths that if you query it well, it can just like nail those. And we have absolutely no tools that do that. So I think you just kind of have to look for like, well, what don't we already have solutions for, and then test both. Like you could test whether language models can do keyword search really well, but usually they can't, and it's just like more ineffective.
Right. So it's more the more almost ambiguous or the more cognitive work is required to get an answer, probably that's better suited to. Okay, thank you for that. That's really helpful. You mentioned this, by the way, that diagram with the chain that represents kind of what LangChain does. That was really fantastic. Did you draw that?
Yeah.
That was fantastic. It's a beautiful diagram. So ChatGPT now has support for plugins that can do stuff, including call external services like databases or web APIs. I'm curious how that fits into LangChain and how they kind of, do they compete with each other? Do they complete the landscape? How does that fit together?
Yeah, it kind of depends the strategic like road that LangChain takes. I know they've just gotten a ton of funding, but I also know that they're like developer focused, right? So like I feel like they're always going to be the developer tooling approach versus like normal people can still use ChatGPT plugins. So I feel like it's going to become. I mean, we also kind of have to watch how like things like Zapier and IFTTT start playing in this space because they already have all the infrastructure and all the audience set up to like do this really well to do this like kind of like really complex, interesting chaining, but also be accessible to normal people. So my current bet is like LangChain stays developer focused and maybe becomes more developer focused, and either OpenAI like invests much more in product and becomes like the Zapier of language models, or literal Zapier just takes over that role.
Right. That's really helpful. Thanks again. I was literally faced with at work like a use case where I could solve the problem both ways, and that's been really helpful. I think I'll stick to LangChain. There's one final question here. There's one final question here by I don't know who, someone from the audience, and I'm not sure how to parse the question. So I'll just ask it as it is here, and then we'll try and figure it out. The question is, if the answers will be predictable, how can we call it an AI? That's what the question says.
Interesting. I feel like it's philosophical. I don't know. Well, this is where I feel like the word AI is so fraught at the moment. I have an entire like essay on this. Like, who knows what AI means? Like, it's like the definition changes every 5 seconds. I think what they're getting at, right, is like were the answers to be predictable, then it would just be like a traditional computing system, right, where it's just like input output. We like see all the functions in the middle, and that we are thinking of AI as something that has these like emergent, unpredictable kind of like very human-like behaviors to it. But yeah, I mean, nothing from a language model is ever perfectly predictable. No matter how much you like nail, like do the prompt engineering and like really like, okay, only give me JSON and this exact output, right, and like fine tune on that. Okay, maybe there's a line where you're like, okay, shoot, that's like just what comes out. But it's like I feel like it takes so much work to get over that line, and it's almost like we're forcing it into something it shouldn't do, is what it feels like a lot of the time.
Yeah. That's I think that answers the question.
Maybe
also,
that was a good philosophical question.
yeah, and with the rise of large language models, I feel like you said, AI is the definition of what we think of it as changing so much. Because if I think back to the early video games, AI was just having a CPU player that plays against you, right?
Yeah.
Awesome,
Yeah,
Maggie.
a calculator is AI. Yeah.
Right, exactly. Yeah, Maggie, thank you so
Yeah,
much
yeah.
for that talk, for the answers.
Yeah.
It's been an absolute pleasure. Thanks again.